Hello, this is Kyle Van Hook. I'm here to show the final milestone for the Universal Asteroid Trooper project, and also the build. But first, I'd like to show all the stuff that I need to. First, starting off menu screens. Let me actually get back to the game. So we're in Unity, right? We're in Unity, and this is the start screen. I made some of the custom things that I made was the entire start screen here, and the neon lights here, or the neon title screen title. And this also appears for the credits, the exit, well, not the credits, the win screen, and the victory screen. Now, starting up the game, and later I'll show you the actual build. Once you load, please. Fluid sound, so you should be able to hear it. So, I have buttons that you can click on. Here, we have a button that leads to the credits screen. Programmer is me. Title screen and background were made by me. And sprites and music were made by Kinney.nl and AbundantMusic.com. We have a menu. We can go back. We have music on the beginning screen. If we start, well, we have enemies. We have a timer. We have a. Let's see, what am I trying to say? I guess what am I trying to say? It's functional right now. It actually probably pretty good. We have a timer. We have a live system. We have a scoring system. We have a system to track enemies. All enemies spawn in at the start. We also have a warp system. As you can see, both the objects. Where's the last one? He's up there. Both the objects and the player and the bullets will warp through the screen. Like right down there. We have meteorites that turn into smaller ones and split apart. We have a victory screen right here. We have the lives work, and it's set to eight lives at the beginning. We have if I run into an enemy, they will explode. That also works for the meteorites. We also see that lives and score and enemies also, well, score starts at 0, enemy starts at the number, in which this case we have 8. Once all 3 lives are gone, game is over. And just to show you, this exit works. The exit works both in the editor or editor here, and also in the actual build. Like this. A lot of the sounds, you could hear sounds like anytime I shot a projectile that was shot, anytime either the meteorites were shot and their health was completely taken down, they exploded, they played an explosion sound. Anytime either the player or the UFOs either collided with each other or destroyed, they made an explosion sound. The meteorites, they have 3 stages. Prefabs. We have a large meteorite, which is basically a large meteorite that takes 3 damage. It will then split into 2 meteorites. As we also have the, where are you? Oh yeah, Death Meteor Destroy, which is a new death script made for the meteorites, which will basically say we'll have a prefab that we want to spawn. We'll have a number of objects we want to spawn. We'll have a spawn point, in which case all of them now have an empty in them, which acts as a transform. Except I think the tiny one, yeah, the tiny meteorite doesn't have the meteor one because we don't want to split. We just want it to destroy once it gets at that point. Let's go to gameplay scene. Da 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 da. All right. I want to at least show the enemy spawner, and then I'll start showing code. Uh, we have a enemy spawner. It takes two prefabs. One's the meteor prefab, in which case we start with the large meteor, and it also has the UFO prefab, where it takes the enemy UFO. And I also think I forgot to mention the UFO does follow the enemy. It does follow the player, and it will try to collide with them. We have a spawn amount, so we can spawn a certain amount of objects. We were always set it to 8, and we were getting 8. And if in some cases you might have noticed there was an explosion that started at the beginning, and our counter might have been 6 or 7. That's because during the spawning, one of the UFOs spawned either into themselves or into the meteorite, and they exploded and died. I think that's actually a feature because I wanted the meteorites to be able to move through each other, but damage any of the UFOs if they touch them because they're getting damaged. They're meteorites. But also, I wanted the meteorites to be able to go through each other and not explode, so that there's like when there's a bunch of little meteorites around, it's more of a hazard. We have a spawn percentage chance. There's a tooltip in it that says it takes between 0 and 100. This is just so that there's like a 30% chance, like a percent chance to have a UFO for spawning during the spawn. We set it to 30, so sometimes we get a UFO. In this case, I'll set it to 0 and do this. And we should, at the bottom, we have 10 enemies, and they're all spawned randomly around the player. We'll do 100, and we should get 100-ish, because there's probably going to be a few of those that die on spawn. Oh, they didn't all die. It does happen, but if you see, yeah, like up there, some of them died because they ran into each other, and those there. Yay. Oh, you also might notice that it takes like a second to register whether or not all the enemies are dead. I had to do that because when I was restarting the game from like finishing a round, starting at main menu, starting again, it would immediately then go to the win or lose screen because it wouldn't have enough. The game wouldn't have enough time to register that new enemies have spawned. So I needed to make sure that it could tell that. So there's like a small any when there's like less than 0 enemies, there's like a 1 second timer that checks to make sure that all the enemies are actually dead. I could probably do that to 0.5 seconds or whatever, but or milliseconds, but I just did that to make sure there was time to register that there were enemies, and we shouldn't immediately go to the end screen. All right. Yeah, this is a good place to start. We have the random enemy spawn. Here's the code. Uh, Prefabs, spawn amounts, spawn percentage. This counter is for actually counting how many loops we're going through. We're using while loops, and hopefully that's fine because we're able to break out of it easily. But as long as the counter is less than the spawn amount, we'll continually go through this whole loop. In which case, this was actually one of the more harder things to do. One of the issues is that when I spawned the meteorites and the UFOs, sometimes the player would be in. Sometimes the meteorites and UFOs would spawn at 0, or somewhere around that range, and they would immediately destroy the player and get like a -10 lives for the player, which would break the game, but also that's not fair to the player starting because they don't have time to react to that. So I took a little bit of time to figure out how to get using the game instance. We have like the size of the screen for the warp. We're getting the minimum X, and we're getting a random range from that number, and we're assigning it to X. And we want to do this at least once but we're checking that while x1 is greater than -5 and x1 is less than or equal to less than or equal to 1. So this is the x, we want it to either be left or right. We don't want it to be anywhere near the player. And likewise, if x is less than 5, and x1 is greater than or equal to 0. They're both basically the same parameters for y, but we changed it to 4 because 5 was like basically going under the y value for the screen. It's not that much of an issue with the warp, but we wanted to at least kind of start on screen at least a little bit. Then from the x and y, we basically get a new spawn position vector. Then during we want a random chance of those enemies to spawn. So we get a random range from 0 to 101. And the reason we get it's from 0 to 101 is, remember, we go 0, 1, 2, etc., etc. So we want from 0 to 100. So we're adding +1 to it. That way we're getting that way we at least have a chance to have 100%. And we're checking here if random chance is less than or equal to the spawn percentage, we'll instantiate the UFO prefab at whatever spawn position we have with no rotation. Otherwise, we'll just instantiate in the meteorite, and then we'll increment the counter, and we'll do this all again until spawn amount has been reached. I think I mentioned the menu has sound. The player has a death sound. He plays. There's I think in a later version we already said that there's sound that you can see sound that you can hear based on distance and which ear would be on. I guess going over this, this is the UI manager. This isn't what I'm looking for. I know this was important. Functionality, player movement. Oh yeah, I might have to go through that. The player movement is used during WASD. There is a random T, which I modified to just be a little bit slower. Pressing the arrow keys will teleport the player. And also, the teleport actually works with a warp. And shift is the shift is the turbo for both left and right shift. This is getting too long. Let's see. We got shooting, that works. Score. We have enemies. We have UFOs. We have UFOs that follow the player and try to collide with them. We have meteorites that collide. We have lives, and you can play the game until you get to 0 lives, in which case you'll go to the game over screen. Have I shown you that? Yeah, it'll be easy. I'll just collide a couple times. All right, there we go. Game over screen. Victory. Yeah, I've shown you that. Screen warp. I've shown you that. Oh yeah. So I guess for the we've already gone over the Singleton pattern, but I should show you mention in the game Singleton pattern for the game over. We're basically getting across different stuff. Say for like sound, we have these audio clips that we all want to play, and they're already in the in our game manager, where they're already all set up and have been loaded in. Say that we want to play where is Death Storm? All right. Say that in this case we want to on the player's death we want to play an audio clip. But obviously, the audio source will be destroyed once the player is destroyed. So we want to make a separate audio clip or audio source at the position the player is at. We can't really load or well, we could load have a sound clip in an object that holds a deaf player, but that's not really helpful. And using a singleton pattern like game manager in this case, where we're getting the instance, which is just the game manager itself, and we're getting the object, the clip sound here, to basically make our lives a little bit easier. We can avoid a lot of the getting objects, getting component from this component to this component, and so on and so on, and just get it from a place where it's stored. The singleton pattern allows us to go kind of a shortcut to have a variable or an object that's exposed everywhere. It's good and bad, of course, because we can readily abuse this sometimes, and it can make code a little bit messy. And it's definitely helpful for like UI for audio. Like you want a sound to play at a certain place, like maybe pick up a coin. You want a little jingle. You want a death sound as the player is dying. Stuff like that. It's also a good place to like store things like the player lives, the score, like time remaining. Oh, also, there is a time limit. It's like 60 seconds right now, and if it gets to 0, you will lose the game. Also, this is where the bounding box for the warp is. It's set to I should probably modify that. Yeah, I'll modify that in the final version and GitHub. But these are public and you can't set them, so I should probably get rid of that instead of having them set immediately. But we've gone through pretty much I think most of the things. Also, this is like some of the game, the win screens. We'll go to in the log, we'll display victory. Where do we set the current? Oh yeah. Oh yeah. The reason the time works is that we want the time to be at least 1 second. And then we then go to no. No, that's not why we do it. We do that because we want to reset the time to the current time right now. Then we go from, I think, if the player is dead. Oh yeah. If damage zones equals 0, then we go to win timer, which then counts down, which then goes to win game. We reset the timer. We go to we load the scene for the victory scene, and that's basically what's happening. We have a pawn controller model. We have a pawn. This is basically the player pawn, where we have all the stuff that's happening. We have all the. Do I have? Yeah, we have. No, that's my new controller. Let me open up a script controller somewhere. I'm blind. There you are. Yeah, that's worked. This is the controller. It basically has all the decision stuff here, where if we press down a key, it'll do an object, do something like shooting, teleporting, running, moving, turning, that stuff. And the pawn is where all the actual commands happen, or the math happens to do that. It's also where we have our health component, our death component, our shoot component. It's also where we make, at start, we make the game manager, the player's pawn equal to this. Is there anything else? Oh yeah, we have multiple abstract classes. Like where is player health is a like player health. Originally, I only had one health component. but as I was making like the meteorite and the player, I needed to separate them in order to do different things. Because like I think enemy health component, yeah, I want to make it so that no, this is different. I'll just find it. Oh, we're getting to 20 minutes. That's lovely. Meteor. Well, actually, no. Death, meteor, destroy. I can show you that. This is a completely different one to the death component, which is the original death abstract class. I'll also get that as well, which is just an abstract class that has one public abstract class called void. Anyways, going up ahead, in this class we have game objects. We have the game object that we want to spawn. We have number of objects, and we have spawn transform. Where during that, we basically have a counter that goes how many that checks how many number of objects we want to spawn, and will increment after every instantiate. Afterwards, while the wild is finally completed and all the instantiation is done, and the counter is to the same number of objects, then we destroy this object. But an abstract class is basically like it's the parent class of an object where we put all the important all the important functions that any child class has to have, that we want them to have regardless of what they do, like the die function or die method. And I probably could have made a second damage on overlap for like the UFO, but I was perfectly fine with having the UFOs die if they touch the meteorite. I just didn't want the meteorites to die. But other than that, I think uh I think oh yeah. The only thing extra is that I think I need to explain is probably the principles of object-oriented programming, which we've done a lot. Every script is a singular script that does something. Like the pawn and controller, we have a pawn that is the object we're controlling. We have a controller that actually controls the pawn and takes user input. We have health components. All of them are related in some way, but they change. We're basically in object-oriented programming. We're encapsulating objects, making smaller objects to do simple functions or methods that we need them to do. And we're making that some objects, like the health function, like the enemy, or like the health components for like the player and the enemies, they will inherit an abstract class, in this case, the health component or the death component. They will inherit certain functions from them, and they'll be able to use them, or will have to use them in order to even be used. And that's for DeltaTime. Everything uses DeltaTime, or like all the movement and all the shooting, anything that we want to move, like the player or the bullets or the enemies. We use DeltaTime because we don't want our game to be tied down to the frame rate. Or yeah, I think that's it. We don't want to be tied down to the frame rate because then that would mean if we were to move this onto an older computer, it would probably work fine. If we move this onto a newer mega computer, the timing would be all off. So use DeltaTime to get the time of the computer and have it run at the same rate. That's why for movement we make sure to multiply maybe a move speed or something by DeltaTime, so that it's working at the same rate. Now, this is a half-hour video. Let me finish this off by showing you the build. you can see, we have 8. In this one, we had set the final spawn count to be like 8 objects. And we have shooting, we have music. We have pretty much everything I should have told you about. We have lives, we have enemies, we have a score to the right. We have an enemy counter at the bottom left, which I think is helpful to at least tell them, hey, there's this many things above that are still alive. They're somewhere in the world. And I don't know what the timer says right now because the sharing screen is on it. But it's there. Where are you? I'm blinded somewhere. I don't see it. There you are. You were right off the little edge. All right. And just to show you, the exit will quit out of the build. There is still a game quitter, like in the gameplay scene. We can quit out the build for both the game over and the victory screens and the main menu. We can start the game. I'll start it again just so I can show the credits. And then we'll go here. Yeah, and I probably collided with something. And this works, but also just show you we can exit out of that. And that's, I think, everything important that I had to show you or talk about. Oh, yeah. I should show you the warp right here, which all it really does is that it's constantly checking the bounds of whatever object this is attached to. And we'll check the position and see if the game manager is less. So in this case, for like this portion, this is checking the game. We want to check our position for the X minimum. So we're checking the current position for whatever this is attached to. We're checking the X minimum. If this is somehow less than the X minimum, because remember, negative, a bigger negative number is less than a smaller negative number. We basically want to make their new vector at the exact opposite. In this case, the max X. And we do this for X, the max X, where we check if the position is larger than max X, where we'll then transform them to the minimum bounds. And it basically does the same thing with the Y positions as well. Okay. Now. Oh yeah, we also have health bars, but you can see that. You can see it on the game. Score, shooting, player movement, audio. The main screens. I already told you that what I did for the Above and Beyond was I made that title screen. I made the planet. I added some existing sprites and made it a little bit better. And I also spent some time to learn how to make neon because I thought the neon would look good. But other than that, that's everything. I'm sorry this was half an hour, but this was as short as I could probably make it and get everything done and get my thoughts on paper. All right, then I guess that's it. Thank you and have a good day.